Okay, ladies and gentlemen, let's see what you remember from the day that isn't today. What day would that be? Friday. The day that isn't today. I am going to ask you for your favorite ternary acid. Oh, how did that happen? Your favorite ternary acid, name one. Just one. Sulfuric acid. Is that ternary? Why is it ternary? Well, it has, what is the definition of ternary?
It has one hydrogen atom and one in a polyatomic ion.
It has a hydrogen ion, in this case it has to have two, and it has a polyatomic ion. And I would like you to name your favorite base that is not sodium hydroxide. Barium hydroxide. Okay. Do you know what this will form? Of course you do, because it says right here, it forms the salt in the water. What are we going to write first? We're gonna write the water, but we're going to write it as HOH. So we are clear that the H came from here and the OH came from there, which leaves us with what? The sulfate and the barium. Which would be written first? Barium. It has an oxidation number of +2. And the sulfate, from your green sheet of happiness, you can see it has an oxidation number of -2. So when I crisscross those together, this is the formula I get. Is that the correct formula?
No.
Why? What do I have to do?
Reduce.
I will reduce it. And so I will cut these off. And so my product would be barium sulfate. Am I done?
No.
I need to.
Balance.
And I'll put it to here. By the way, that is not me doing this wiggling. I can't move my hand that fast. I don't know why that's doing that. All right, moving on. All right, tomorrow you will be doing a titration lab, and in our room we will be using the equipment as it is shown. In the other classes they will not, because we're using the Chem 2 equipment. Woo-hoo. So write down what you need to write down, and then we'll talk about it. Okay. So tomorrow, as you will see, we will be using this contraption, and this contraption is called the burette. What it is a very skinny, long graduated cylinder attached to the tip, and the tip is controlled by this thing called the stopcock. If you move it one way, it allows the contents, the analyte, to go into the flask. If you move the stopcock the other way, it stops liquid from flowing. What you put in the burette is a solution of known concentration. And for these titration concepts, we always take a base and an acid, and they form a plus water. So in tomorrow's lab, you are going to be taking a base of known concentration, and when we talk about concentration, what unit do we usually use? molarity. We will know the exact molarity, and we will know the exact volume, because we can read it off of this graduated cylinder. And to it, we will be, and we will add that to the acid, whose volume that we know exactly, but the concentration we are unsure. So as we add this base to this acid, salt and water are being formed. This is indeed, what type of reaction? It is a double replacement reaction, also known as neutralization. We're waiting for it to be neutralized. We add into it an indicator. You know 4 indicators, name just one.
Like, I don't know.
Nope. You have worked so far with 4 indicators. Name one of them. Thank you to those people who are at least attempting to find the answer to this question. Litmus paper. That wasn't so hard now, was it? Thank you very much. Litmus paper. Tomorrow you will be using the indicator known as phenolphthalein. Phenolphthalein in an acid is what color? Looking again for the correct answer, which is clear. Clear. Okay. At the moment, we have more base than more acid. What color will the phenolphthalein turn? Magenta color. That's what the end point of this reaction will be tomorrow. Okay. But I would like you to walk away from the end point of titration is when the indicator changes color. The end point of the titration is where the indicator has changed color. For you, that's when you stop the titration. That's when you close the stopcock. That's when you want the titration to be done. Why? Because it's very close to where the equivalence point is. Hang on for a moment and I will show you the equivalence point. All right, just stop for a minute here, okay, for a second, and look what we're doing. This is the graph of a titration. In this graph, and this is the volume here, we start out with, in our Erlenmeyer flask, my drawing has gotten, we have the base. In the burette, this time, we have the acid. When we start out, we have, so we're adding the acid to the base. When we start out, we've had 0 of the acid, and the base has a pH of 14. As I continue to add acid, the pH starts to slowly go down. Then it rapidly goes down. And this part of the graph, when it's rapidly changing, halfway between there is what we call the equivalence point. And the equivalence point is defined as the volume of titrant added, where the moles of the acid equals the moles of the base. Write this part down on your sheet. You wrote all that down? In AP Chem, we use a pH meter, which is an electronic device that determines in a titration the exact point when the moles of the acid equals the moles of the base. That's the equivalence point. You have lots of writing to do. Please note that this is a altered equation. Make sure you change your equation. Your equation is missing this part and this part. That is very necessary. This part and this part. MA stands for the molarity of the acid. VA stands for the volume of the acid. Write down the problem because you're going to solve the problem just like they do. I would like you to list your variables on the left-hand side. There is one hydrogen ion in hydrobromic acid. Its molarity is 3 molar. You're using 0.45 milliliters. In these titration neutralization problems, you may use milliliters. The volume of the base is 80 milliliters. Calcium hydroxide dissociates into a calcium ion and 2 hydroxide ions. So the number of hydroxide ions is 2. Do the math portion as well, please. What you see on the board is what you should have on your notes. Okay, ladies and gentlemen, when you're done, do the example problem, raise your hand when you have an answer, and let me check it. Yep. Yep. Put your finger to the base. Yep.
So it's one as well.
Did you flip them? Yes. Yeah, okay. All right, ladies and gentlemen. All you do is look at the number of atoms in the corner. There's one hydrogen atom. Everything's numbered in just as well. There's one hydroxide group. So each one is three. Make sure this is what you have on your paper. Good to go? All right. More writing. So pH is what we use to put a number towards the acidity. So far, all we've done is say it's acid or it's base, but now we have degrees of how acid it is and how basic it is. tell me this. If I have hydrochloric acid that has a pH of 1, and I have acetic acid that has a pH of 5, which one is more acidic? The 1. Remember, it goes kind of backwards to where you're thinking. The lower the number, the more acidic it is. Alrighty. Now, this requires you to think about math for a moment. Can you do that? Have you been doing logarithms in math? Yep. You'll be doing logarithms here too. All right, yeah, they're not so bad. Okay, so here we go. This is a piece of pH paper, and at the end of class, we will be testing anything you have on you to see what the pH is. But right now, let's look at this. Here is something with a pH of 7. It is totally neutral. Pure water has a pH of 7.00. Your blood has a pH of 7.41. Your blood must stay in a very, very narrow pH range in order for you to survive. We used milk of magnesia in that rainbow demonstration. It has a pH of 10, which is acidic, neutral, or basic? Basic. It's basic. Oven cleaner, which is a very dangerous chemical, please be careful with it, has a pH of 13. Okay. Look at tomatoes. Sometimes give people problems. You know, if you drink a lot of tomato juice, you eat a lot of tomatoes, people with acid reflux are told, or an ulcer, are told to stay away from them. Why? They're very acidic, and if you did get acid reflux, what would you do? You would use a base. How many people have ever heard of an antacid? Tums is an antacid. What does it do to excess acid? It neutralizes it. Good. All right. Let's get on to the math part. Stop before you get to part E. Or, actually it says C. A, B, C, D, C. Let's have a refresher on how to use your calculator. The first example they give us is a hydrogen ion concentration of 1 times 10 to the negative 2. You need to figure out the pH. In order to do that, this is how you would put it in your calculator. The negative log, so that's what you should see right now. And then you add the number. Let's remember how we add an exponent. The coefficient first, second, EE gets you to put the exponent in, -2, close parentheses. To do a pH problem, it should say, actually it didn't register the negative log, let's try that again. The negative log of 1.0 second EE -2 close. Okay. This is what your calculator should say. Press enter, and there's your pH, 2. You may now try the practice problems